A stationary front, also known as quasi-stationary front, is a weather frontal transition zone between two air masses, where neither air mass is strong enough to advance into the other at least 5 knots, about 6 miles per hour or about 9 kilometers per hour, at the ground surface. On weather maps, it is shown by a solid line of alternating blue spikes pointing to the warmer air mass and red domes pointing to the colder air mass. When a cold or warm front slows down to less than about 6 miles per hour, it becomes a stationary front between the two air masses. A single air mass can be modified by extensive land and water surface temperature differences over enough time to become two unique air masses separated by a stationary front. Cold air and warm air usually flow about parallel to the stationary front, in about opposite directions along either side of the front. A stationary front usually remains in the same area for hours to days, and atmospheric shortwaves may move eastward along the front. The stationary front is about stationary at the surface, but some warm air rises up and over the cold air, pushing enough to keep the front about stationary at the surface, and pushing some adjoining cold air up, back, eddying, and mixing along the cold frontal zone aloft over the cold air mass. Stationary front slopes are usually gentler than their originating cold front slopes, and steeper than their originating warm front slopes. A wide variety of weather may occur along the stationary front. If both air masses are drier, then sunny to partly cloudy skies and no precipitation. If one or both air masses are humid enough, then similar to a warm front, cloudy skies, prolonged precipitation, and sometimes storm trains or mesocyclone systems. When the warmer air mass is very humid, heavy, or extreme precipitation can occur. Stationary fronts may dissipate after several days or devolve into shear lines. A stationary front becomes a shear line when air density contrast across the front vanishes, usually because of temperature equalization, while the narrow wind shift zone persists for some time. This is most common over open oceans where the ocean surface temperature is similar on both sides of the front, and modifies both air masses to correspond to its own temperature. This sometimes also provides enough heat energy and moisture to form subtropical cyclones and tropical cyclones at the surface. Stationary fronts may also change into a cold or warm front, and may form one or more extratropical or mid-latitude cyclones at the surface, when atmospheric shortwaves aloft are stronger and air masses advance fast enough into other air masses at the surface. For example, when a cold air mass advances fast enough into a warm air mass, since the advancing air mass is cold, the stationary front changes into a cold front.